Let's take a look at the acs-aem-commons bulk workflow manager. So I'm on the acs-aem-commons website. I'll click through to the bulk workflow manager v2 feature page, and this has a bunch of information you can read through on how to use this particular tool. This video is going to take us through the setup and execution of using the bulk workflow manager. Before we get started though, the bulk workflow manager is simply a tool that manages and orchestrates the execution of workflow within AEM. There are a few different methods that workflow can be executed, and we'll be taking a look at those. So the first thing we want to do is make sure that we have the latest version of acs-aem-commons installed. So if you go to releases, you'll be able to download the latest releases. Remember the 3.0 release line is for AEM 6.2, and the 2.0 line is targeting AEM 6.0 and 6.1. You'll want to at least use version 2.8.0 on 6.0 or 6.1, or 3.4.0 on AEM 6.2. So I have already installed acs-commons on my local AEM 6.2 instance. What you'll want to do is head over to the sysadmin UI. This is the old classic UI, and we have to use this right now because we actually want to navigate to Tools, acs-commons, Bulk Workflow Manager, and we're going to be creating new pages under here, and each page is going to represent an execution of workflow. So we're going to take a look at a few different types, and I will name these workflow pages accordingly. You can name these anything you want. So I will name this AEM workflow. Double click and open, and we'll have a form that lets you define how you want workflow to be executed. The first thing we'll see here is we have a runner type. So these runners define how Bulk Workflow Manager will execute workflow. The default is just AEM workflow. So this is really just going to engage the normal AEM workflow engine and start putting payloads under normal AEM workflow. And this will be the first one we'll take a look at. So let's keep this selected and go down to the next field, which is query type. So we have a bunch of different ways we can query content to put under workflow. My favorite is Query Builder, just because it's a pretty simple syntax. And for this example, we're going to be running the DAM asset update workflow, which is probably the most popular use case for this. So we're going to query all of the DAM assets under content DAM. And I just have a 6.2 GA install, so I have a bunch of geometrics content and things like that. And the search node relative path. So this next field allows you to specify a relative path that can be added to the path of any result from your query up here. From this query, we know we're going to get a bunch of DAM assets. If we wanted to specify the original rendition to be the actual payload itself, we could put JCR content renditions original. For each result of this query, this relative path will be added, and whatever resource is located at that path will be used as the payload for the workflow. In this case, we actually don't even need this. Most of the DAM workflows will be able to operate on any node under the DAM asset itself. The workflow model will list all of the workflow models available in AEM. We'll see a little later on that any transient workflow will actually be marked with transient in this list, so it's very easy for you to see if it's transient or not. But we're going to be picking our DAM update asset workflow. You can pick really any workflow you want, since we're using the AEM workflow runner here. Up to this point, really what we've done is perform a query that collects all of these resources and put them under normal AEM workflow using this workflow model. So the next set of fields we'll want to set up are how the bulk workflow manager will actually execute this work. So the key value proposition here of bulk workflow manager is it manages the amount of work put under workflow at any given time. If we had 1 million assets, we certainly wouldn't want to put 1 million assets under workflow and try to have AEM just handle that, because that could become problematic and very costly for AEM to manage that work itself. The max number active workflow field simply defines the number of workflows that bulk workflow manager will put under workflow at any given point of time. So effectively, we shouldn't have any more than 100 active workflows if this number is 100. For this example, we're going to drop this down to 25. The next field is the workflow job queue width. To take a look at this, we're going to jump over to our Felix console, go to Sling and Jobs, and we can scroll down until we find our queue for Granite workflow. So here it is. And we'll see here that currently my max parallel queue width is 4. So that means I will have 4 workflows being executed at the same time. This number probably will need to be tuned based on the number of cores on your system. So if you want to be doing work other than just workflow execution, you'll probably want to free up some of your cores for that work. So for instance, my machine here has 4 cores. I want to edit this, and I'm going to drop it down so only half of my cores are used for my workflow execution. We can see here it's by default set to -1, which is going to be all of my cores. I'm going to set it to 2. And then I will want to go back to Bulk Workflow Manager and update my queue width to whatever that was. The next field is the average time to process one asset in seconds. And this just helps Bulk Workflow Manager figure out how often it should check to see if the batch of active workflows is completed. So in this case, I have a lot of small images that don't take very long to process at all. So I'm going to drop this down to 2 seconds. So this field is just a calculation based on the top 3 fields. And what this is saying is every 25 seconds, it's going to check to see if there is any room available within this active workflow queue and add more items to it until 25 is hit. The last is timeout. So when you deal with the normal AEM workflow engine, on occasion you can run into payloads that for whatever reason have trouble being processed by the AEM workflow engine, and they can sit there and kind of get stuck in loops or process forever. Here you can set a timeout. So basically if an asset gets put under processing for more than say 60 seconds, that it will force terminate that particular payload and log it as an error so you can check it out later. Usually this number you can keep relatively high, so you can set it to 2 minutes or 5 minutes. So the benefit of this field is it prevents the bulk workflow management from getting gummed up by rogue payloads that might not be processed properly. Do note that any of these failures will show up at the end as failures, so you can go back and investigate and figure out why they didn't process correctly. So the last 2 fields are checkboxes. The first is auto throttle. What this does is it leverages the acs-aem-commons throttle task runner to ensure that the CPU and memory usage on your AEM instance doesn't exceed some upper limits. We can check out this configuration. This is actually configured via OSGI in terms of the limits that are imposed. So if I go to Felix, go to the configuration manager and search for the throttle task runner service and open it, you can see that we have max CPU percentage and max heap percentage. If CPU ever hits 85%, it will throttle this process and not load up any more work until the CPU drops below 85%. Similar with the heap, if the heap ever exceeds 75%, it will again throttle the work. So this is typically a good safeguard. If you're doing literally nothing else on the system, you may be able to uncheck this. But again, I typically like to leave this checked just as a safeguard here. Lastly, because we're using the AEM workflow and our workflow is not transient, it's going to create the usual etc workflow instances, node structures. And if we are executing this at scale and say we have tens of thousands or hundreds or even millions of payloads that we want to process, we probably don't want to keep around all of those nodes, as that can slow different aspects of AEM down. Checking this will simply delete the workflow instances after they are successfully completed. If they fail for any reason, they will stick around so you can investigate later though. Now that we have this all configured, we can give this a run. It will go through and perform this query that we defined. It'll collect the payloads and actually store its own index of payloads under this page that we created. That's under acs-commons, bulk workflow manager, AEM workflow. If this query is very large, please be patient because it can take some time to go through and collect all of the payloads for processing. We will get a summary here. So it'll tell us the runner, it'll tell us the status of the runner, the number of items completed. As you can see, we already hit a full batch, so we processed 25. It tells us we have 75 remaining because we had a limit of 100. We have 100 total down here. Gives us our auto throttle status. It'll show us our CPU and our memory. And keep in mind that these are the bounds when throttling will happen. It may go over this at times, but it should continually drop back down after it pauses work. Over on the right column, we have the query type, our query statement, our batch size, our batch timeout, and our batch interval. It also gives us some information about the workflow that we're actually putting under, our started date, time taken, and a projected time remaining. We also have an option to stop the bulk workflow. And I may have been too late to do this, but let's see if I I got it in time. But if you have a large run, you can actually stop the workflow and then resume it. Do note it will say stopping until it's stopped. And typically it will take about a full batch interval for it to go from stopping to stopped. If it takes longer than that, then there's probably an issue that you'll want to investigate. We did get the stopped status. Come down here and it is stopped. We're at 70%. We can then at our leisure come back and resume it as needed, and it should go through and complete the work here. Also down here at the bottom, you can actually see the current batch that's being run. So it'll try to show you what is being executed, just to give you a little bit of visibility. You also get failures listed if there's any issues. So as you can see it, because of my query, I actually requested some DAM assets that cannot be processed by the DAM asset update workflow, and they will show up here in our failures list down at the bottom. If I actually thought that these were valid payloads, I could go back and investigate and try to rerun the workflow on these to see if it would work and or figure out why it's not processing these. When it's done, it will show you that it is 100% complete, the time taken, and it'll also link out to the workflow history, which is just the normal AEM workflow console, so you can investigate any particular issues with your failures here. So we just took a look at using the bulk workflow manager, leveraging non-transient workflow using the AEM workflow engine. What we're going to do now is jump back, and we're going to take a look at doing the exact same thing, but we're going to be using transient workflow. So let's jump back to our sysadmin console, go to Tools, acs-commons, bulk workflow manager, and we'll make a new page because this is a new execution. And I'll just name this AEM workflow transient. We'll go through this a bit more quickly. So the first thing you'll notice here is it actually does say AEM workflow non-transient at the top. And this is driven by the workflow that is selected. So again, we're going to just run the DAM asset update workflow. And you'll see here that this is non-transient. So the first thing we'll need to ensure here is that this workflow is actually marked as transient. So we can just go into the usual workflow console, either classic or touch, open up the model, go to the page properties, check the transient workflow checkbox, hit OK. When we go back to our bulk workflow manager page and refresh this, and we select DAM update asset, we'll see there's actually parentheses transient here at the end, and that's indicating this is a transient workflow. So when I do this, we'll see that it actually updates here from yellow to blue and says we're using the transient workflow engine. The reason why it went from yellow to blue is transient is typically far better suited for applying workflow at scale because it doesn't have the full overhead of the AEM workflow engine. It has some drawbacks in that it's difficult to identify failures, and we'll see that. It doesn't track the etc instances and have that level of granularity and visibility. But typically in terms of just scale and performance and getting this job done, transient is the better choice between AEM workflow transient and non-transient. So again, I'm just going to do the exact same query here. And you'll see here, this wording has changed just a little bit. So we have max number of Sling jobs. So because transient workflow doesn't actually use workflow instances, it uses Sling jobs, we can kind of manage it that way. And this will effectively do the same thing as before, where a bulk workflow manager will try to limit the number of jobs for the transient granite workflow topic to 100 and not put any more in than 100. Again, for this case, let's put it down to 25. Our job workflow queue, again, this can be configured through the Felix console here. We have our max parallel to 4. Again, let me go ahead and drop this to 2 because I don't want to use all my cores. I only have 4 cores on my machine. Then we have the average time to process one asset, same as before. Again, we can drop this to 2 since I have some small assets. And we have our computed batch interval. So this number effectively defines how often the bulk workflow manager will check to see if we have any more space in our Sling job queue to add more work. We also, again, have the option to do the auto throttle. So I typically leave this on. You'll notice we aren't purging any workflows, and that's because transient workflow does not create workflow instances to purge. So it's a non-issue here. Let's do it just like before. Start workflow. It's going to go through and collect our payloads, and we should start seeing the percentage here tick up. It's chugging along. we have 75 completed. Our failures are unknown because since Transient is managed via Sling jobs, it's very difficult for us to tell if anything has failed. So you'll need to check your logs for that. And as you can see down here, it instructs you to check the logs for the workflow execution to detect failures. Everything else is effectively the same, and it will tell you once this has been completed. So those are the two ways we can execute workflow using the AEM workflow engine. And next up, we're going to look at how we can execute workflow using synthetic workflow. So we'll want to go back to Tools, acs-commons, Bulk Workflow Manager. I'm going to make a new page for a new run, and I'm going to call this synthetic workflow. The first thing we'll want to do here is select our runner type. So previously we had used the AEM workflow engine here. We're going to be picking synthetic workflow single-threaded. So synthetic workflow is an abstraction provided by acs-aem-commons. It's actually very similar to Transient Workflow, but the big difference is it doesn't use Sling jobs to manage the work. It's actually an API that wraps the aem-cq workflow processes or aem granite workflow processes and executes them as straight Java. So it doesn't engage with any of the Sling job management or aem workflow instance management. And depending on what you're executing, this can provide some stability and efficiencies. So there are two methods for doing this. The first is synthetic workflow single-threaded. So effectively, what this will do is it will take all of the payloads that we define by our query, just like we did before. And it will take all of these payloads and pass them to whatever workflow model we select here, but it will wrap that workflow model as a synthetic workflow model so it doesn't engage with Sling jobs or the AEM workflow engine. It's worth noting that synthetic workflow has similar constraints as Transient Workflow. It really needs to be a serial workflow model, which is effectively a single decision branch, and it should be comprised of all workflow processes. So DAM asset update is a great candidate for this because this is a single. So the DAM update asset workflow is a great candidate for this. As you probably remember, it's effectively just a big list of workflow processes. So a few things that synthetic workflow can't handle are things like decision trees, participant steps, ECMA steps, things like that. So if you have a workflow that you want to run, you'll want to make sure that it's comprised of only the workflow process steps. You can also click through to this link to read more on what is supported and what is not supported. The rest of the configuration here is actually pretty straightforward. What this will do is we'll run this query as usual, and then it will simply loop over these results, and it will run each payload through the synthetic workflow model, processing it. And there's no multi-threadedness in this single-threaded synthetic workflow runner. Since we only have 100 items in our results here based on our P limit, I'm going to set the batch size to 10. Again, we have our auto throttle, so before it processes any payload, it actually checks to see if the CPU and memory is under our thresholds, and if it is not, then it's going to pause and wait for those things to drop below our thresholds before it spins up more work. So let's start this. As we can see here, it's already starting to process work. So there you go. We have 95 completed, 5 failed. We ran it as synthetic workflow, and it took about a minute to do. So the last way to run this is very similar to the synthetic workflow, however, it's multi-threaded. Let's again jump back to our misadmin, create a new bulk workflow manager page, and we'll call this one synthetic workflow multi-threaded. Just open this up, and let's select the synthetic workflow multi-threaded runner type. So this is going to effectively do exactly what we did before, but it's going to use the acs-commons fast action manager, which is a multi-threaded work management tool provided by acs-commons to perform this work. The fast action manager can be tuned in terms of the number of threads it will use to execute the work. We can go back to our config manager and go back to our throttle task runner service, and you'll see that we have max threads. This again should not exceed the number of CPU cores, and if you're doing other work other than this workflow, you probably don't want it to consume all of your cores, just so you have computing power left over for the other work. So again, in my case, I'll drop this to 2. Come back to my bulk workflow manager, and I'll just put in our usual query. We'll pick our workflow model. Again, we'll do our update asset. Because this is using synthetic workflow, this has all the same constraints as we discussed before. This next set is unique to the synthetic workflow multi-threaded in that fast action manager has the ability to retry. Usually what you'll want to do is just set the retry count to 3. Occasionally, especially when you have a lot of payloads to process, you can run into an instance where a payload will fail, and if you retry, it will succeed. So it's nice to set this retry count to 3, and typically this will take care of any issues here. So if you do change this retry count to 0, you will get the option to set a batch size. So this really kind of determines the number of payloads changed before a commit will occur to the JCR. And the reason why this requires 0 retries is because if a retry happens, this entire batch is effectively wiped out. It doesn't save the batch even if there's a single failure. So typically, setting a retry count to 3 is totally fine, and having a commit per payload is fine. But again, if you're going up into the super high levels, you may want to set the retry count to 0, set larger batch sizes, and handle any failures after the run is completed. And we also have this retry pause, so it'll wait 200 milliseconds after a pause. Now we can just start this. And again, looks very similar to what we've looked at before. It's collecting all the assets, and it's going to start running these. And as you can see, it's already almost done because we're using the Fast Action Manager to control the work, and we're doing this in a multi-threaded manner as well.